Hello, let's talk about glucagon. The only name I've got is glucagon, so I don't have any shorthand version or anything like that for this one. We're going to take a look at everything. Now, we're not going to look at diseases and disorders for glucagon. So, what is the stimulus? What is the reason glucagon gets secreted? It's due to a low blood sugar, hypoglycemia. Remember, hypo means low, emia is referring to blood. So, this is low sugar in the blood. Normally, this is going to occur during a fasting state. So, could happen, for instance, after it's been a long time since you've eaten a meal. This is when blood sugar could drop and glycogen, uh, glucagon, I'm sorry, would be secreted. So the normal range for blood glucose, let's say it sits in this range about 70 to 120 milligrams per deciliter. And then if it goes above that, insulin will be secreted. If it goes below that, glucagon will be secreted. So glucagon is the discussion for today as far as low blood sugar goes. So where is it secreted from? Well, you have a picture here of the pancreas. That's not the blood vessel, but the pancreas. Below that, uh, the specific place within the pancreas is going to be the islets of Langerhans cells. Remember, the acinar cells are where you're going to get the exocrine uh, products from. The endocrine system is going to come, and the hormones are going to come from the islets. So the specific cells within the islets of Langerhans that are going to actually secrete glucagon will be the alpha cells. And there's a bunch of different kind of cells within that islet. We'll talk about the other cells a little bit later, but alpha cells are the ones we're going to focus on today. So where are these alpha cells? They're going to secrete glucagon. Where is it going to go? It's going to target the liver. And the liver is going to make sure that glucose gets in the bloodstream. So there are two ways that can happen. Glucagon is going to stimulate the breakdown of glycogen, which is stored in the liver. Now, glycogen is the storage form of sugar. You got a bunch of glucose molecules. They're going to all kind of bind together and form this big, huge molecule called glycogen, and that's just the storage form. Glucagon is going to break that glycogen molecule down into glucose molecules, and that glucose is then going to enter into the bloodstream. So that's one way. The second way is to take amino acids, which would be called gluconeogenesis, is the process by which this is going to occur. And it's going to take something other than glucose and turn it in something other than glycogen, and turn it into glucose. So when we have anything but glycogen being converted into glucose, it's called gluconeogenesis, and that's going to be the amino acids. So we're going to take the amino acids, turn them into glucose, and put that in the bloodstream. And this is just showing you that when you take glycogen and turn it into glucose, that process is called glycogenolysis. So we're literally splitting the glycogen molecule. The class is going to be a peptide hormone. It's 29 amino acids long. You don't have to know that, but I just always like to tell you guys that kind of stuff. And that is it for glycogen. So really very short.